solve for those variables. First thing I'm going to do is grab x on number 22. You've got a corresponding angle, works out real well for x. I'm going to get that vertical angle for 50, and then I've got a straight angle here, 120 plus y is equal to 180. So y is going to be equal to 60, and that'll give me both of those. 2y and 80 are corresponding angles on these parallel lines, so they're going to be equal. I've got 120 rather, and 4x, they're going to be supplementary. Pull that 120 from both sides and you'll get x equal 15. On my next one, don't try to set up any kind of crazy system. Get those x's solved for each other. You know that they're same side interiors, therefore supplementary. 180. Move the 20 to the other side. Pull the 16 off. You're going to need x equal to 10. That's going to give you 125 degrees for here. That's really all you need. Z is going to be a vertical angle. Y is going to be an alternate interior angle, so they will both be equal to that. On number 25, they don't give you enough information. I'm going to tell my class that the extra information here is going to be these lines are also parallel, and that will allow you to solve for y. Without them, there's no proof. That you know what I'm talking about. So on this one, alternate interiors here, we'll get x equal 14 once we divide off. If this is 90 degrees, then we have alternate interiors here for this one, or same side interiors, so supplementary, also 90 degrees. 42, 48, 48 and this much have to be alternate, have to be congruent as well. So we'll give 48 is equal to 6y minus 6. That'll make 54 is equal to 6y. Y is equal to 9. This one. Now, you've got two givens. They're going to put them in different places, and you need to watch how the proof flows to see where you put the given. Example, we've got our blank, our first given, and they're going to claim that 1 is congruent to 4. Why are they congruent? Because these two lines are going to be parallel. And that's what we need to list first. If lines parallel, then your corresponding angles are congruent. And that's necessary that we put that one here, and we grab our measure of angle 1 is equal to 90 and throw it in down there. We get that order correct. Then they're going to substitute in. You'll notice we switched from congruence to equality. We said that angle 1 is equal to 90. Angle 4 is also going to be equal to 90 by substitution. This one, weird. We don't see it a lot. This is going to be the definition of straight angle. If you've got any group of angles that are on a line together, they make 180 degrees. They're then going to substitute in, instead of angle 4, 90. So substitution. You can slap property of equality if you want on top of both of those. They're going to subtract the 90 from both sides. So the measure of angle 2 plus the measure of angle 3 is equal to 90. And then complementary, definition of complementary. If they add up to 90, they are complementary by definition. Construct a line parallel through point X that is perpendicular to line L at point Y. Parallel to L goes through point X and is perpendicular at point Y. So, and a line. So I'm going to do both of these at the same time. I'm going to take and get myself a perpendicular line here at Y. First thing I want to do is get 2 points equidistant from Y and construct my perpendicular line there. Cha. So, pokey on Y, swing through, get a couple of points, grab this one up here. It's going to give me that perpendicular line. And now I want to go parallel through X. Now this is going to be a bit of a stretch. Let's see what we can do. So I'm going to put my pokey on X because that's what I want to be parallel to, or perpendicular. Oh, gracious. There we go. There we go. So we cross right here, get myself a little hash, cross right here, get myself a little hash. And what I've done here, if you want to be perpendicular to a line, example, we want it to be perpendicular to L at Y. If you want it to go through, that's where you put your pokey thing. All right, we put the head of our compass right here, and we swing through to get the two marks that we make the hashes from. If you want to be parallel to L, you're going to have to be perpendicular to the line we created. I want this parallel line to go through point X, so I need to put the head of my compass, the pokey part, on X and use that to swing through. Now it's a giant swing, so it's a little bit, it gets a little bit aggressive. But once you make those hashes with X, you get that parallel line. All right, and it'll run through the point that you put your pokey on. Super handy. 2-column, no help proof. Love them better because you get to follow your own reasoning. Given that angle 5 plus angle 3 is 180 degrees, prove that A is parallel to B. You have a couple of different options. What I'm going to do is use that, well, we've got the equals. I'm going to prove that 5 and 6 equal 180. I'm going to substitute in at that point, drop angle 5 from both sides, and I'll end up with 3 is congruent to 6. And then I'll transfer that, 3 is equal to 6 rather, transfer it to congruency, and I'll have alternate interiors congruent, and that'll make my lines parallel. We'll start off, measure of angle 5 plus the measure of angle 3 is equal to 180. It's going to be given. I'm going to make a fancy step here. I don't generally take it. We're going to say that the measure of angle, angle 5 and angle 6 are supplementary. It's going to be the definition of linear pair. Linear pairs are supplementary angles. And then angle 5, gracious, plus the measure of angle 6 is 180. And that's going to be the definition of supplementary. So now I've got both of those sets equal to 180. I can now say that the measure of angle 5 plus the measure of angle 3 is equal to the measure of angle 5 plus the measure of angle 6. By substitution, we're switching that 180 out. And then I'm going to subtract off angle 5 from both sides. I'm going to call that out. Measure of angle 5 is equal to the measure of angle 5. Kind of like, hey, I'm about to do this. It's reflexive. And that will leave me with the measure of angle 3 is equal to the measure of angle 6. Subtraction. Transfer that to congruency. We'll call that the definition of equality. If things are equal, they are also congruent. If angle 6 and angle 3 are congruent, then A is parallel to B. Because if our alternate interior angles are congruent, then our lines have to be parallel. That's that first one. Second one, given that these two sets of lines are parallel, we have AB and FE, BD and FG, those are all parallel. Prove that angle B, this one, and angle F, this one, are supplementary. Now, how am I going to do this? I'm going to prove that B and C are the same using corresponding angles. I'm going to make C and F supplement using same side interiors, and then using the congruent supplement theorem, I'm going to make them all. I'm going to make B and F supplementary. All right, here we go. Start off with my both givens. So we'll go BA is parallel to FE, and BD is parallel to FG. It's given. And I'm going to start calling things out. Angle B is congruent to angle C. It's given. And then angle, now it's not given, gracious. If lines are parallel, then corresponding angles are congruent. You know what, we'll go through the fancy way. Measure of angle B is equal to the measure of angle C. Definition of congruency. I'll use an equation for this. Then I'm going to say C and F are supplementary. If my lines are parallel, then my same side interiors are congruent, are supplementary. Now I'm going to take and get me an equation I can work with. Get myself, rather, an equation I can work with. So the measure of angle C plus the measure of angle F is 180. Definition of supplementary. And I'm going to replace angle C, oh there we go, angle C with angle B. The measure of angle B now plus the measure of angle F is 180. I've substituted that value in. And that's going to give me that angle B and angle F are supplementary by the definition of supplementary. Make sure that you take a look over all this stuff. System's going to need to know that. Your theorems, be able to write out the theorems and postulates in the if-then form for the parallel line. Remember, if what you know, and then what you want. All right. Example, we want these two to be supplementary. So if the lines are parallel, then supplementary for same side interiors. Straight edge and compass, be able to determine this one is big. Remember, spherical triangles are between 180 and 360. All right, they're somewhere in there. And then your regulars are equal to 180. Be careful on that. Good luck.